Hello everyone. It has been a while since I uploaded a new video. Today, I finally have some free time, so I want to make a very important tutorial for you. How to perform real-world measurements and testing on an ECU. This is a basic and very important step in ECU repair. Once you understand this part, you will know the working principles and you will know how to measure and test an ECU correctly on the bench. So please try to watch this video until the end. I believe that after watching the entire video, you will have a clear understanding of the proper repair method, and you will be able to apply it in your learning as well as your daily repair work. In this tutorial, we will analyze the power circuit of the ECU. We will go through the working principles and understand how each section of the circuit operates. This knowledge will help you handle real fault cases more easily in the future. I will also try to make more tutorial videos like this, covering many different ECU models from many car manufacturers so you can have the most detailed and practical view to apply directly in your repair jobs. In today's video, we will start with the engine control ECU series ME 17.9.11, ME 17.9.12, and ME 17.9.8 used on Hyundai and Kia vehicles. I will help you understand the entire hardware structure of these ECUs, the function and the role of each IC, and how to measure and test each part of the circuit. This will help you become familiar with this ECU series so you can repair it confidently, no matter what fault you encounter. Before we begin, let me give you a quick introduction to the ME 17.9 ECU family. The ME 17.9 series has three versions: ME 17.9.11, ME 17.9.12, and ME 17.9.8. Their working principles are the same. The difference is in the application. ME 17.9.11 is used on manual transmission vehicles. It does not include the transmission control circuitry, so the mainboard is simpler and has fewer components. ME 17.9.12 and ME 17.9.8 are used on automatic transmission vehicles. These two versions have identical hardware designs. The only difference is the MCU they use. ME 17.9.12 uses the Infineon Tricore TC1762. ME 17.9.8 uses the Infineon Tricore TC1767. And to begin, I will guide you through the power circuit analysis and the measurement procedures on the ME 17.9.11 ECU. Because its circuit layout is simpler, it will help you understand everything without feeling overwhelmed. In general, it is not different from the ECUs used on automatic transmission vehicles. They all use the same ICs and the same working principles. The only difference is that the transmission control components have been removed and the layout of the parts is a little different. So how can we truly understand an ECU? As many of you already know, almost all ECUs from car manufacturers today do not come with hardware schematics. Even the datasheets for many ICs are not available to the public. This makes real repair and diagnostics very difficult for all of us. So how can we learn the circuit and repair it properly and systematically? Today, I will show you a very important technique. This is a method that most technicians use, but very few people will ever tell you about it. So please believe me, you will not hear this from anyone else. If you find this video helpful, please consider giving me a simple thank you. It will give me more motivation to make even better videos for you. Thank you very much. To do this correctly, we need to invest time and analyze an ECU that is working normally. This is exactly how I learned to repair ECUs and understand their circuit principles. Whenever you work on a new ECU model that you have never opened before, the first thing you must do is invest time to study and analyze it. Only then can you understand the wiring paths, the power rails, and how the signals flow inside the ECU. With that understanding, you will be able to repair the ECU much more easily in your future work. First, we need to understand the Pinout diagram and the basic operating principles of an ECU. This is fundamental automotive electrical knowledge that every technician must know. If you are still not confident with this part, please take some time to study it. I also have a video that explains how to look up electrical wiring diagrams, and I will put the link in the description below. We need to clearly understand the conditions required for an ECU to operate. What power supplies does the ECU need? Which voltage appears first and which voltage appears later? Only when we understand this sequence can we analyze the circuit correctly and accurately. For all ECUs, the very first power source is the bat line. This is the direct voltage from the battery, and it is always present even when the ignition key is turned off. The second group of power sources appears when we turn on the ignition key, the ACC line and the IG line. Some ECUs can already start operating with only these two power inputs. However, to analyze the circuit in deeper detail, we need to understand another important power source, the main relay output. This is the primary power feed controlled by the engine ECU through an intermediate relay. It supplies power to various systems on the vehicle and ensures safety during operation. So in summary, we will consider the main relay power as the last power source that appears in the ECU's operating sequence. The main purpose of understanding the order of the power supplies is to allow us to apply each voltage line one by one. Whichever power comes first, we will apply that one first. Then we use a multimeter to measure the voltage on the mainboard and see exactly which areas receive that power. From this information, we can analyze the circuit much more easily. Now please follow along with me. We need to take clear photos of both sides of the ECU. These photos will help us record all the measurement points during the analysis, and they will be extremely helpful for our repair work in the future. Now, we will start supplying power to the ECU. Because this ECU does not have the BATT power input, the first power line we need to apply is the IG line. So I will apply the IG voltage and begin taking measurements. On this ECU, the ground pins are pin 3 and pin 4, and pin 18 is the IG power input. Understanding the pinout diagram of an ECU will make your repair work much easier, even when you are not repairing the ECU itself, but working on the vehicle's electrical system. When you know the exact pin locations, you can quickly find the power lines at the ECU connector, and you can measure them accurately and safely. After turning on the IG power, we begin supplying power to the ECU. Then we start tracing the circuit and checking where the IG voltage goes and which IC it reaches inside the ECU. Please remember that in this first step, we only supply the IG power. For this ECU, the IG power must be activated first. Only after that can we trace the circuit, take measurements, and analyze the board correctly. During the checking process, we use both voltage measurement and continuity testing to identify each circuit path clearly. Try to measure all the points on the ECU mainboard to locate the IG power line. Here it is. The IG voltage reaches this point. When I follow the printed circuit trace, I can see it goes to pin number 19 of the IC 40048. Now I will turn off the power and perform a continuity test. Please remember that whenever we switch between voltage mode and ohm mode, we must turn off the power. The IG power line has many branches, so I will place one probe on one branch to make the test easier. When I test with the buzzer, there is no beep. This is normal because the buzzer only works when the resistance is very low, from 0 ohm to just a few ohms. So I switch to resistance mode. The power line may be going through a resistor to limit the current or through a diode for reverse polarity protection. Here it is. From the IG input pin to the point we measured, the resistance is about 3 kilo ohms. This means the IG power passes through a 3 kilo ohm resistor before it enters the IC. Now we will find the location of this resistor. We will follow the printed circuit trace to see where it goes. From the input pin number 18, I do not see any visible trace. It may be routed on the opposite side of the board, hidden under the socket, or it may be running inside the inner layers of the PCB. This ECU uses multiple PCB layers, so our only option is to trace it manually by measuring voltage on the resistors or by checking continuity. I will use the voltage measurement method. Measure each resistor one by one. You will eventually find the correct one. Here it is. I found it on the back side of the main board. There is a circuit trace running through the inner layer and reaching this point. We will mark all the measurement points we found, including the points that connect the two sides of the board. Mark them on the picture we took earlier. This will be very helpful for future repair work because this position is very close to the power filter capacitor. As you already know, the power filter capacitors on Kia and Hyundai ECUs often fail. They leak chemicals, damage the board, and break the circuit tracks. Having a marked reference image will help us compare and diagnose more easily in the future. And remember, this is the IG voltage line, so label it clearly as IG. Now I will check this resistor to see if it is really around 3 kilo ohms. It is correct. The line goes through two resistors of 1.5 kilo ohms in series. Because of the resistor tolerance, I measured almost 3 kilo ohms. We can round it to 3 kilo ohms. Right next to it, there is also another resistor of about 3 kilo ohms connected to ground. In my opinion, this resistor works like a load resistor to stabilize the voltage. Now, we will check continuity from this resistor to the IC to confirm it. It is correct. I will now draw this circuit on paper to make the analysis easier. We will draw the IC as well. Pin number 19 of this IC is the IG power input pin. The IG voltage is supplied through a 3 kilo ohm resistor network. I will draw this resistor network to make it clear. This is the IG power circuit going into the IC. So we have found the first power circuit. This is the IG power supply to the IC on the ECU mainboard. This is the first condition for the IC inside the ECU to start operating. To continue our analysis, we need to think logically based on the working principle of the vehicle's electrical control system. If you work in a garage and repair vehicle body electronics, you will already understand this principle.